Did Shiva air it?
He is airing it intensely. And I'll let you, at the moment I say good, we are good to go. You guys can start.
Yes. So, hi guys, this is Yashashwini, student dean engagement. Like, we'll be just waiting for 5 minutes so that we can have more number of viewers. Did Shiva air it?
He is airing it intensely. And I'll let you, at the moment I say good, we are good to go.
So, yes, guys, we are going to have a session about artificial intelligence and machine learning. So, we have Mr. Vinay Kumar, who's going to take our session. Currently, he's the director of Expert Bridge, who has done his post graduation from IIM Ahmedabad. And I hope you guys will utilize and get the wider knowledge from him and keep interacting with us. Vinay sir.
Hi.
Yes,
Yashash,
you can take it, sir. It's all yours.
thanks for the introduction. And I'm very happy to be interacting with the students of HITM. And it would have been great if this interaction was face to face, but anyway, we are at least connecting online. So, what I understand is that all of you have a good exposure to artificial intelligence and machine learning. So, I will not be going into any algorithm or the basics of it. What I would like to do today is to give you an industry perspective and also going into some of the foundational philosophy of artificial intelligence and machine learning. Uh, and towards the end of it, if you have any question, I would be happy to take it. So, artificial intelligence and machine learning, although it's being talked about very intensely for last maybe 5 years or 10 years, but if you see the history of artificial intelligence, it's actually quite old. It goes into the 1950s, and it was in 1956 that for the first time a conference on artificial intelligence was organized. So if you see from that time, it's roughly going to be around 70 years that we have been talking about artificial intelligence um, in the field of computer science. But now it is gaining momentum, and this momentum appears to be a sustainable momentum because of convergence of various factors that we will talk about in a moment. But before that, we must realize that artificial intelligence starting from 1950s till now has passed through what we call as the AI winter. It means that everything was put into the cold basket, and people were not really, or investment was not coming in. Scientific research focus was not there on AI for quite some time, and it happened because the promises which appeared to be the promises which were made, they were not really fulfilled. And the main reason was that the computational power which was required to enable some of these things were not really available. So although the concepts were there, the ideas were there, but the other facilitators or other enablers, like very cheap and very powerful computing power, was not available. And we will see that now that those things are available, artificial intelligence is definitely taking off. But before we go into that, I would like you to take a much longer perspective as to why artificial intelligence we are talking about. And in a philosophical perspective, this is, where is it coming from? So if you see, from the historical times, for thousands of years, we as human race have always been trying to improve our limited capability that as a human race we were endowed with. As a human race, we are not that powerful. Many other animals are much more powerful than we have, uh, than we are. We don't have that kind of, a sense of a smell or sense of sight which many of the other animals have. And therefore, it has been a continuous endeavor for thousands of years for the human beings to be able to extend our capabilities. And if you see, it is in that context that we extended first our muscle power by domesticating animals. So the things that we had to do ourselves, like lifting weight or transportation, or many other things that we used to do only with our own muscle power, we found that animals could do it maybe much better because they were more powerful, and therefore we domesticated those uh, animals. And then in the 18th century, we were able to replace even those animals by machines. But if you see, ultimately, what the machines do is that what we used to do thousands of years with our own muscle power, and once the machines come into picture, then our own muscle power actually becomes so insignificant that we don't even talk about it now. We only talk about the cranes for building machines, and wherever just the human power is being used, we see that those societies or those work are of primitive nature. You can't really construct a very high-rise building with just the manpower, and that's how you see that the pyramids, which used to take tens of years to construct, we are able to construct the buildings higher than that even in much lesser time. In the recent time, the process of which started a few thousand years back was we also wanted to extend our memory, and that's that has been done to an extent that now even for memory we don't really rely on human beings. We go to Google and want to get the information that we want. Just maybe about even 30 or 40 years back, nobody thought that human memory would be externalized, that human memory or the ability to memorize will not be in the human brain, but it will be on some computer or some cloud somewhere. So initially we developed the writing techniques, and now we have the memory chips on computer, to which we on which we depend on things which would be done with memory. I mean, uh, even maybe 20 years back, in our education system, there was a lot of emphasis on memorizing things. Unfortunately, we continue to do the same to a large extent. But if you see, in our day-to-day life, or even to succeed in organizations, we don't really have to have a very powerful memory because everything can be accessed. So we see that our muscle power has been externalized. Even something which was thought to be very human like memory, that also we have been able to externalize. And then the next step comes that not just the memorization, can we also externalize learning. And what is learning? Learning is ability to use our existing knowledge to see that how we can react to the new situation, new environment, and do new things. So the question that people have been asking, and that's what the origin of the, philosophically, if you can see, that's the origin of the machine learning. That having seen that muscle power can be externalized, having seen that memory can be externalized, can we really externalize the learning? And that's what the stage we are in. And then the maybe next thing to ask, it may happen in next decade, it may happen in next century, I don't know. But maybe the next question to think about is that can we develop a machine which can also think? And there is a subtle difference between the learning, intelligence, learning, thinking. And so the next stage could be that can we really build not just the learning machines but also the thinking machines. So you should see the entire thing as a progression of the human endeavor to acquire or to externalize many of the capabilities, and therefore to multiply these capabilities in many ways. And once we externalize it out of the uh, human body, out of the human capability, then you see that we are able to multiply it several times. Just take the example of the muscle power. Once it was externalized to machines, then we were able to increase the capability of those machines multifold, maybe thousands of fold. Nowadays we don't even say that, can the, humans run faster than a car? I mean, the comparison is not there anymore. Can the human beings lift the weight that the cranes can lift? Because once we have been able to externalize, then we were able to increase its capability, thousands and multiples of thousandfold. Same thing happened in memory. Once we were able to externalize it, then our the ability of the machines to memorize things is thousands and millions of times more compared to the human beings. We just can't memorize, anything compared to what the machines can have in their own memory. Now the same thing we are seeing, and we are at a very early stages of seeing that in the process of learning, once we are able to externalize it, then we see that the capabilities to multiply the capability multifold, thousands of fold, is actually happening now. If you see, whatever we take, you know, uh, I'll just give you a few examples. When we the human beings learn and master a game like, say, chess or AlphaGo, and I'm sure that all of you are aware of those examples. I'm not going into those examples as such. But human beings take several years to master those games, but machines now can learn those games, to play those games within minutes, and they can start beating the world champions by having a training in just for few hours or few days. Similarly, now that autonomous vehicles have come in, the auto driving cars, and therefore once they are linked to the network, whatever mistakes that is being done by any one computer can be now being learnt by another self-driving car. And therefore, suppose there are 10,000 Tesla cars on the road, while we learn only from our own mistakes in driving, or maybe a few things which our coach or guide or person who is teaching us driving would tell us. Now, with the interlinking of the self-driving cars, every car learns from the mistake made by every other car, and therefore they are learning maybe about 10,000 times or a million times faster than a human being would do. So we are seeing that in the field of learning also, our the ability for the machines to learn can be actually multiplied by thousandfold or a millionfold, and that is what is creating this excitement around artificial intelligence and machine learning, which was not there earlier. So let's first try to define what artificial intelligence is, what machine learning is, and then we'll try to see the differences. what are the subtle differences between them. So artificial intelligence is a theory and development of computer system able to perform tasks normally requiring human intelligence, and these are the keywords. Okay, so we are saying that now we are defining artificial intelligence as the capability that we can transfer to machines, or we can induce into the machines or the artificial devices, which enable them to perform things which humans perform, like visual perception, speech recognition, decision making, translation, or for that matter, if you see any of the things that we do as human beings. And the basic differentiator between a dumb machine and the human beings is that we are able to react to the situation given the changing environment, and we are able to take decisions. We are able to evaluate different options mentally and decide that which one would be the best action to take. If we introduce those capabilities into machines, that is what the artificial intelligence is. And that's where we start with small things, and then the machines start doing more complex thing. And that's where you will see that in the literature, what was assumed to be artificially intelligent maybe 2 decades back, we don't consider those things as having AI today, because those things have become routine. Now coming to machine learning, as humans learn, can we really make the machines learn? So the artificial intelligence, if you see, is enabling an artificial device to function something like human beings. So for example, if a machine can play chess, maybe a few decades back, it could be called artificial intelligence, but now it has become so commonplace that ability to play chess by a machine, we don't even consider that as really having an AI. But AI as such, artificial intelligence as such, is providing the intelligence to the machines. And this intelligence can be induced into the machine in different ways. So, for example, we could write a specific code, and then based on those rule based code, the machines could act intelligently. Now, we can ask the question that whether the Excel sheets that you use, is that intelligent or not? Of course, it is intelligent because it is able to do the computations. Once you give the instructions, once you give the data and give the instruction, it is able to do things which earlier just the human beings used to do. So, yes, there is a lot of intelligence in Excel sheet. Similarly, there is a lot of intelligence in many of the software systems. So, having knowledge, having intelligence, and the ability to learn, these are, if you see, these are the different progressions. So the question is that, is my computer or is Excel a learning system or not? Or is Wikipedia a learning system or not? So what happens is that even though these systems are very intelligent, it means that they are able to do a lot of good things, but are they learning? Learning means that you are able to build upon or create new knowledge out of the existing knowledge. So even if you have the entire Wikipedia downloaded onto your laptop, and even if you have softwares like say Excel or Microsoft Word on your machine, they are very intelligent system. But as you switch off your machine in the night and open it up in the morning, they are no more intelligent compared to what they were previous day. Why is it that? Because although they are intelligent systems, they are intelligent machines, they are not learning. So that's the exact difference between, that's the difference between having intelligence and learning. So learning means that you are able to create new things, you are able to get new perspective and ability to apply that into the new scenarios compared to what it was yesterday. And in that sense, the every intelligent system is not really a learning system. And the example is your laptop. There are so many intelligent softwares, but as you go from day to day, unless you upgrade the system, unless you download a new application, there is nothing new in your laptop. Okay, so the fundamental question that we have to ask is that uh, can the machines really be made to learn at all? Okay, we'll go into that question, but let's see some of the basic definition of the machine learning and why this understanding would be important, that we will be able to differentiate between artificial intelligence and machine learning. So artificial intelligence is making an artificial device act intelligently. Now that intelligence can be induced into them by either writing a rule based code. For example, the you know if you write a tree based search algorithm, now that makes the system more intelligent because it is able to search things more, uh, uh, it is able to search things faster. And even things like when the IBM machine beat Gary Kasparov in playing the chess, then it was also based on the tree search algorithm, because the system could actually search through millions of the possible moves and gives weightages to those moves and see that which one would be the best one. So even those things are the, so even when you are coding for it, which are called the expert systems, if we are able to encapsulate the human knowledge through human development of software, that also can make a machine intelligent. Okay, and so that will also be qualified as artificial intelligence. But the machine learning is that we are acquiring the knowledge not by explicit coding, but by allowing the software to learn from the data that we expose to it. Okay, so there is very little of the explicit coding is involved, and the machine learns from the data. So that's the machine learning aspect of it. So machine learning is the science and art of programming computers so they can learn from data. That is what we do from the in the machine learning. And now that's not a necessary step in making intelligent artificial devices. Okay, so artificial intelligence, for making the machines artificially intelligent, we can provide all the rules. We can write every rule into the software, but that's not really learning by the machines. That those are the rules which the we as human beings can code and put that into a machine, and then the as per those rules, the machines can act intelligently. But when we learn those rules by itself, when we make the machines learn those rules by itself and not defining explicitly from our end, that process is called the machine learning. And so in that process, we provide the data, we provide the algorithms, and then the machines learn the rules from the data itself. So that's the machine learning. So, if you see the second definition, machine learning is the field of study that gives the computers the ability to learn without being explicitly programmed. That is what I was telling you, that we give the data, we give the algorithm, we give the computing power, and then the machines find out the rules or the patterns by itself, and that's what the machine learning is, and that's what is different from what we call as the development of expert systems. So the expert systems is that expertise lies in the human brain. We extract that, we put that into different rules, we code those rules, and then we put that into a machine. So that's the expert system development. So machine learning is very different from the expert system development, where the rules are being configured or being figured out or being discovered by the machines themselves. A more technical definition or a more engineering like definition of machine learning would be that a computer program is set to learn from experience E, that is any given experience, with respect to some task T. Now, this some task T is very important because the machine learning as we have today, it is not able to really scale through different types of tasks. So you can train a machine to interpret maybe the language, but that particular program will not be able to work for the computer vision or identifying the objects. The same program will not be able to uh, make decisions or optimization or make the prediction of the right price for a given house, or it will not be able to make a recommendation to you as to what is the next video that you should be seeing, or what is the next item that you should be buying on Amazon. So right now we are talking about training the machines learning to do a specific task. And how do we know that the task is being done better compared to the uh, previous experience? That is, we need to have some performance measure, which we'll call the P. So a computer program is said to learn from the experience E with respect to some task T and some performance measure P. If it performs a task, that is, if it performs on T as measured by P, improves with experience E. Okay, so that becomes no a lot of jargon there, but the basically the thing is that more experience that the computer has, it actually performs better, which is measured by some measure P, in performing any task T. So the more experience I gain in doing a task, more the better my performance becomes. So that's what the key of the machine learning is. So now if you see the difference, uh, let me first go to these slides and then I'll come back there. Okay. So in this one, if you see, currently what we are doing in the software is we process data. So data was what the programs processed. So we wrote the programs first, and what are these programs that we write in software? These are the different rules that we code. Okay, so the rules are given by the domain experts. Developers convert those into a computer code, and these are the computer codes which will process the data. So if you're writing a banking software, how does the bank operates, that logic would be given to you by the banking domain experts. Then we take those requirements, we give it to a group of developers. These developers would write the program, and then that program will now process the new data which comes in. So if you make a new deposit, it will go and add it to your existing balance and things like that. But in machine learning, we are not doing the entire programming. We are just exposing the machines to data, and then the algorithms itself decide what the next course of action should be or what the rules are there. So that way, if you see, the machine learning is in a complete contrast to the expert system or the software that we are developing today. We are so in the current development process, the steps are that we find the logic first, and then with that logic, we process data. In the machine learning, we say that give me the data. By seeing this data, I will be able to figure out what the logic is or what the underlying rules are. So the machine itself identifies the rules. Okay, and that is what is the learning, because by seeing the data, it is able to identify how things are operating, what is the pattern, and it is not very different from what we have learned as children. I mean, how did we learn only those things to which we are exposed to, and then as children, if we were exposed to, say, the language spoken in our homes, we learn that language. So a household in which Telugu is spoken, they learn Telugu. A household in which English is spoken, children learn English. So even we learn only from the data that we are exposed to. Similarly, the machines also learn from the data that they are getting exposed to. So machine learning is the inverse of programming, and therefore, now this is a complete paradigm change. So the question we were asking was that we want the machines to learn, but at a fundamental level, we have to ask the question that can the machines learn? And that's where we need to do some level of abstraction, and we see that if we identify the underlying principles, then we can externalize this to a device and make them perform that function. So, for example, the birds fly. Now, until we understood the principles of aerodynamics and understood that how birds are able to fly, we were not able to create an aircraft. Okay, several people, they strap the wings to their arms and try to jump from the cliff. They were not successful. Many of them died in the process because they were just trying to imitate the birds without understanding the principles of aerodynamics. But when we understood the principles of aerodynamics, then we were able to create aircrafts. And then you can now see that once you understand the principle of aerodynamics, then you start seeing the birds as the biological implementation of aerodynamic, the principles of aerodynamics, and you start seeing the aircrafts as the mechanical implementation of the principles of aerodynamics. So, what is more important is the principle. If we understand the principle of aerodynamics, then you start seeing birds as the biological implementation and the aircraft as the mechanical implementation. And once we understand the principle, then you can see that now there is no comparison between the birds and the aircraft. Aircrafts can carry much more weight, they can fly for a much longer distance at a much faster speed. So the biological implementation you will see in nature, once we have understood the underlying principle, then the mechanical implementation or the artificial implementations, and this topic we touched upon earlier, become much more powerful. Now, extending the same example that we took, that once we understood the principles of how is does the memory operate, it means that how the information is stored and retrieved, we are able to externalize it and make much more powerful machine in terms of memory. The same thing happened to communication, and now the same thing has happened to learning. So the question here is that if we are able to understand how the learning takes place in the human mind, then we will be able to externalize it and maybe make those machines much more powerful compared to what we have. Any human can learn, we can learn it much faster. So this simile will actually help you uh, understand a lot, that the comparison between the birds and the aircraft. So if you are able to understand the principles of aerodynamics, then you see the birds as the biological implementation. So if we are able to understand the process of learning or the principles of learning, then human mind or the human brain becomes a biological implementation of a learning device, and the machines or the artificially intelligent machines or the machine learning algorithms, they become uh, mechanical or the electronic implementation of the same principle. So yes, fundamentally this is possible. Now the question is that why are we talking about today, even though we started the journey about 50, 60, 70 years back? Why are we talking about today? There are three things which is essential for the success of the machine learning and artificial intelligence. The first one is, of course, the computing power, because as we will see, and if you have done the experimentation with some of the algorithms, you see that the computing power, it requires immense computing power, and that computing power has become available today. I mean, I don't need to tell you guys, all of you know that how, based on the Moore's law, and even in your lifetime, you would see that how uh, computing power which you have in your hand phones is actually much more than the supercomputers used to have just about 15, 20 years back. So computing power has now become very cheap, and it is becoming very powerful. And also, because of the cloud computing becoming available, we can actually get access to the supercomputing power sitting at our desk. So computing power itself has become very affordable and very powerful. The second thing is that, as we said, that uh, if we want learning machines, then we need data, because it is the data from which the machines learn, and data has become available in plenty, because all of us are now using, as the spread of computers and then later on the mobile phones has become more and more data we have. And some of these things, you already know that today we are generating data every year, which we used to know, the if you see the cumulative data generated by the mankind from its beginning till today, now we are generating that much data almost every year. So that is the kind of explosion in the data, and that's what we call as the big data. And this data is not only structured data; this data is also unstructured data in the form of, spoken or written language, or the videos and the weather forecast, or now it is also coming not just from the human beings but also from the sensors, which we call as the IoT or the Internet of Things. So now the data being generated by the sensors in different places in your in the machines that you have at home, the sensors that you have in the fields, which can be used for agriculture, the sensors that you have for the weather, all these are generating immense data, and that's what we have got the access to the big data. And the third thing is the enhancement in algorithms and the architecture. Um, a big revolution came when we mastered this, when this deep learning algorithms came in, and this was the deep learning algorithm and the optimization algorithm which goes along with the deep learning, which we call as the back propagation, which is based on the simple principles of calculus, but that was generalized only in 2010. And that's where the deep learning is just about 10 years old, and that was a big enhancement in the algorithms which help the machines learn. The combination of these three things coming together has made it possible for the uh, machines to learn much faster. Just 1 minute. I think yeah. And the good part is that this trend does not really appear to be ending. It's not that it was a one-time phenomena. We are still seeing that the computing power is going on increasing. In fact, earlier we used to talk about the Moore's law, where the computing power was doubling every 18 months. But now with the and but that rule was on the CPUs. Now with the GPUs coming, now we are talking about doubling of the computing capacity every year and not every 18 months. And now some of you would have followed the progress being done in the quantum computing. So quantum computing is not commercially available now, but with the quantum computing, we are not talking about this doubling of the capacity every 2 years and things like that. If you have seen that about 2 years back, Google came out with the quantum computer, where they said that whatever can be processed in 10,000 years by the fastest supercomputer available, it can be the same amount of information can be processed by the quantum computer in just 2.5 minutes. So you see the the quantum jump in the computing power, where 10,000 years versus 2.5 minutes. It looks very bizarre, that whether it is possible at all. But yes, it is possible. And just 2 weeks back, China has come out with its own experimentation on the quantum computer, and they are saying that it's not just a few times. Their quantum computer is able to do the computing 2 billion times faster compared to the fastest supercomputer that we have available today. And the scientists are hoping that maybe quantum computer, given its complexity, they feel that it's not less than 10 years that it will become commercial. But yes, then maybe we are talking about 10 to 15 years from now, the quantum computers will become available, and their computing power would actually be billions of times faster compared to what we have today. So the progress is, still the path is accelerating, and the amount of data that we are going to get as we have, more and more people start using the phones for more and more things for more and more time. The big data that is getting generated either through the sensors or through the phone or through the other applications is also going to grow. So it looks like that we are just at the beginning of the machine learning and artificial intelligence revolution. It's not we are not even the midway. We are definitely not towards the end. We are just at the beginning of this revolution, which is being enabled by a large amount of data, by very cheap and very affordable and very powerful computers, and also enhancement in the algorithm. So there is a long way to go here. But the question is that as engineers, what is more important, what is more relevant for you and I is that, okay, these enhancements are happening, but these enhancements, then can I do something about it? Or what can we do as engineers with these, facilities which are becoming available? And because most of you are not going to go into the research part of it. We have to see that how we are able to implement this in our lives. How can we create new apps, how can we create new machines, how can we create new robots with the information that we have available. And that is what is becoming possible today. And therefore your focus should be on identifying the use cases, on identifying how the machine learning capability can actually be implementing for can be implemented for solving a day to day or the real life problems. So let me talk to that talk on that for a moment. So I'll skip a few things. All of you are aware of these three different types of machine learning: supervised learning, unsupervised learning, and the reinforcement learning. So I'll not spend too much time on those slides. Let me directly go to that how we can use the machine learning and artificial intelligence in our real life. So I'll skip these slides on what is okay. I'll spend some time on deep learning because that is a widely spoken thing today. So I was talking about the deep learning revolution, which started in around 2010 when the back propagation algorithm was generalized. So what is deep learning? Deep learning is what we call as the neural network. So in our minds also, what happens is that when the information comes in, this information is processed in stages. So for example, in identifying whether it is a car or a dog, our human brain also first takes the information from the photons or the light rays which enter our eyes. Then these are processed in stages. That is, first of all, in our there are neurons which identify the shape, the color, and then in first stage it will identify that whether it has a round shaped thing. Then it will identify no, that round shaped thing is a wheel, and then there are other attachments, and then it will be passed on to the next layer of the neurons in our brain, and these will say that okay, if these are the shapes and these are the colors, then it looks like that this is a car. Okay, so it happens in stages, and that is how the neural networks are also done, where if you see there are different hidden layers. So we get the information, what we call as the input layer. Then it is processed in different stages, and we can have n number of hidden layers here. And at each stage, the information that we receive from the input layer is processed, and then certain things are dropped because they are not significant, and remaining things are getting passed on to the next layer. And therefore, the information that we receive, it gets processed in different stages, and then in the end, we are able to identify, or we are able to generate an output, which will be that whether this is a car or whether this is a dog. So it is the similarity between the network that we create uh, in the networks and the way that our brains function, or the neurons in our mind function, or in our brain function. That is why these kind of architecture is called the neural network. If you see here, this is a picture of our neurons in the brain, where there are different dendrites which receive the signals, and these signals are nothing but the information in the input layer that we have in the deep neural network. Then these are processed here, and then they are passed on to the next layer of neurons, which will do the next level of processing. And as you study our brains also have these specialized neurons. So there are neurons which identify or which process light. There are neurons which process sound. There are neurons which process the temperature and things like that. So similarly here, you will have the different types of layers which process different types of information, and then in the end it is able to identify. So summarizing these things, you see that we first talked about the artificial intelligence. This one is the largest block, and machine learning is a subset of that. Why? Because all artificially intelligent machines need not be the learning machines. So, for example, if we put certain rule-based software into a robo, that it performs in the defined fashion, it is still an artificially intelligent device. But that robo is not learning from the experience because it goes on performing with the same rules that we have encoded. But it is still an artificially intelligent machine. But if we also introduce the capability where, based on, if you go back to the definition that we have said, that with every experience E, so it means that every time that it does new iteration of the same task, then it learns new things and it is able to perform better. So if we put those things into, say, a robo, so to start with, suppose you build a robo with what we can call as the expert system robo, where we have put the rules. So the robot tries to move into a room, and we say that, okay, if there is a if there is something the shape of which is like a table, then you turn left. Now if you put in front of if not a table, but if you put a chair, since that shape would be different, the robo will not be able to turn left. It will go and crash into the chair. So that was the limitation in the expert, rule driven system, because the rules are become very, difficult. You may argue that why not to write a new rule for if there is a chair, but the thing is that you have millions of types of object, and therefore you can't really, write a rule for each and everything. So you will have to write a rule for a table, a chair, a cot, and everything else. But if we introduce the machine learning and we say that, okay, we feed the different types of images and say that if anything like this is there, so the difference is that rather than defining the rules, now you are saying that if anything like this is there, so it will see the images of, thousands or millions of objects, and then it will define a rule by itself, and if something like this is there, then I have to either turn left or right in order to avoid a crash. So that becomes the machine learning part of it. So machine learning is a subset of the artificial intelligence. And then we talked about the deep learning. So deep learning is a specific method of machine learning where we use a specific architecture called neural networks. There are other ways of machine learning. So for example, we can use the supervised learning, unsupervised learning, regression, classification. There are several other classical methods through which the machines can learn. But the deep learning is becoming the most popular because the neural networks are becoming very effective tools of making the machines learn. And why is that happening? Because one of the specific reasons why deep learning is so effective and deep learning is becoming so popular is because the deep learning algorithms are able to identify the non-linear patterns much better compared to the other classical statistical algorithms. Okay, so in nature, if you think, if you see, there are hardly anything which is completely linear. Almost everything is non-linear, whether you see the structure of a tree, or how the mountains, shapes of the mountains or hill, or how the rivers move. Nothing is actually linear, and so happens even in the human generated data. And therefore deep learning is finding a much wider application because it has a stronger capability to identify the non-linear patterns. So in the deep learning, if we are, say, applying into the face recognition, this is how actually it does step by step in a very similar fashion that the our brain processes an image. So if we have this raw data as this image of this girl, then it, at the first level of neurons, so if you see here, this is our architecture we have, where we have different hidden layers. So this input is actually the pixel data of this image. Then, as it passes through the first few layers, it is able to identify what we call as the low level features or the edges. Then, in the subsequent layers, it will combine those edges, and it is able to identify and categorize what we can call as the mid-level features. And then towards the end, it is able to combine the mid-level features and say that this is a face. So in the first one, it will just identify certain edges, maybe the straight line or curves. Then it is able to see that whether there is an eye or a nose or an eyebrow, and then it will able to identify that, okay, in this image I have the eyes and the eyebrows and the lips and the nose, and this is the positioning of these, and therefore it must be a human face. Or if there are different types of the mid-level features, then it will be able to identify that this is not a human face, this is a dog, or this is an cow, or things like that. So that's how in different stages the deep learning happens. But the point to note is that deep learning actually, the we should not extend the simile between how the brain functions and how the deep learning happens beyond a point. But yes, there is a similarity in the way that once we have the input, then the data is processed in different layers, and different layers go on aggregating the low level features into mid level features and high level features, and that's how it is able to identify, if we are applying that in the computer vision, it will be able to identify a human face. If we are applying that in the uh, natural language processing, it will be able to identify which syllable or which word is being spoken and things like that.
Yes, sir. I think we have few questions here. If we can wind up the session, we can go with the questions we have.
Sure. Just I would like to take just one or two things. Yeah, these are the two slides I want to run from my side, and then we'll take the question, if that's fine with you. So the point I was trying to make is that having understood what is machine learning and artificial intelligence, the key question before us today is that how do we really apply it? And it's not very difficult. It is left to our imagination that how we are able to apply some of the logic into different areas. So for example, all of us know that the face recognition is now a very commonplace algorithm. You use that on Google Photos, the same thing is available on Facebook. But if you apply your mind that, okay, if I can identify of one face from another, if I have the images of, say, the eyes being taken, can I differentiate that if whether one eye is having the symptoms of diabetic glaucoma or not? It means that whether diabetes is likely to onset in a person's body or not, that can be found out by seeing the images of the eye. Can you also extend that if I have the MRIs of the different cells, can I identify the cancer cells? Can I identify the fractures from the X-rays? All of these, if you see, will work on the same principle, which distinguishes one face from the other. Similarly, you can apply the same principle into manufacturing. So, for example, if I am manufacturing a mobile phone, then can I identify if there is a scratch on either a front or a back? Because that's also then I am distinguishing image of a glass with a scratch with an image of a glass which is not having a scratch, and that should be much simpler compared to identifying or differentiating one human being from another. So there are different applications that you can think of. Using this, people are now identifying whether a painting is fake or not. And uh, so on the other hand, if you take some of the examples of the natural language processing, we are able to use that on Google Translate. We are able to use that with Alexa and Siri. The question is that how can you extend this technology into healthcare? Can it be used for generating the voice for a person who has lost his voice? Can we generate this for doing a real time translation? That is, uh, if I am speaking to a person who speaks only Korean, then I speak to him on phone here, then on the fly the translation happens and that person will hear in Korean. And if that person speaks in Korean, I am able to hear that in English. Can that kind of application be developed? Or also now, the film subtitles or even the dubbing, can that be done with the help of the machines? rather than somebody humanly dubbing a Telugu film into Hindi. Can we develop a system which will hear the voice, and then it will do a translation with the same accent, and the emphasis for the anger and love and all those things? Can that be really built into that? In that case, all these movies can be released into almost all the language across the world, simultaneously. Is it possible with the given technology? Yes, it is possible, but some more work has to be done. So what I would like to urge you is think about the artificial intelligence and machine learning as enablers through which you have to just think about the use cases in different fields, and the capability is actually available. So if you are learning AI, if you're learning machine learning, the main takeaway for you should be that how really can I apply any of these into solving the day-to-day life problems, and that will give you the opportunity to become millionaires and billionaires of tomorrow. Thank you. Yes. Now we can take the question.
Yes, sir. So we have Sagar. As we just have 5 more minutes for the session, let's be quick about the questions. So, what are the prominent areas where AI is going to make a huge change in 2021?
Okay. So let's not see that in the given time frame of 1 year or 6 months or 2 years. But yes, the as I was mentioning that its ability to make the difference in different areas, and people are working in all the areas. As I see that in our context, in the context of in India, one of the key things to work with is agriculture, which is not much of a work is being done there, although the capabilities are substantial. And you, you would have already read about the government initiatives of the smart cities in. So government of India under its AI mission has identified some 5 6 areas. Some of them are agriculture, education, smart cities, logistics, and what we call now as the manufacturing 4.0. So these are the 4 5 areas where a lot of investment is being made, and there is a conscious effort from the government to make it successful. Now, some of these things you would have heard about, but I'll give you some example from agriculture that how it can make a real difference. Uh, the artificial intelligence enabled vertical farming is actually now giving you the produce what with the traditional farming. So in 1 acre of the artificial intelligence enabled vertical farming, we are able to produce, and this is a real data, what we are able to produce in 720 acres of the traditional farming. It means that the productivity that we have in artificial intelligence farming itself is what you get from 720 acres, we get just in 1 acre. So that kind of possibilities are emerging. But yes, from the government's perspective, from the Indian focus perspective, it is smart cities, smart learning, that is in the field of education, agriculture, and you know, I mentioned a few things, a few other things. Yes.
Yes, sir. So, the session is gonna end in 2 minutes. So, I just want to tell all the viewers that we'll definitely have one more session regarding, or I'll be posting, sir, all the questions that you have asked. As we are running out of time, uh, I thank Vinay Kumar, sir, for being here within the short notice and putting so much of efforts for making the presentation and interacting with all of us. Hope if colleges are gonna open, we definitely would love to have you in college physically and interacting with students.
Yeah, it's my pleasure again interacting with all of you and looking forward to more such interactions. Thank you.
Thank you, sir. Thank you so much for being here. And this is the